do a couple of them. It's going to say graph the system of inequalities. Have we done that already? Okay. Name the coordinates of the vertices of the feasible region. Have we done that? Yes. Okay, that's what. Those are the last three problems on the worksheet. Okay, that's what they're talking about there. So if you can't tie those words together, that's what they're talking about. Name the coordinates of the vertices of the feasible region. This is going to be the new part. Find the maximum and minimum values of the function for this region. Okay, so you notice what's new underneath your inequalities is a function in two variables, because you see how it's f of x and y. Okay. So that means the function is two variables. Where do you think those two variables come from? Where can we find an x and a y? On the graph. And more specifically, which ones are we going to use? Vertices. We've already done that. We've already found the vertices. So this is going to be the new step, is they're going to give you this function. You're going to take your points. Here's the list of their points. You're going to plug x in for x and y in for y, and you're looking for the minimum and the maximum values. So the maximum here would be at 1.5 and 3. The minimum would have been at -2 and 6. And that's what they write. So this part here, this f of x, y, the table and the statement, that's what's going to be new from stuff that we've already done. Okay. Some of these equations will look a little bit different, but else things to point out, you see this first one right up here? We haven't seen anything like that before. But all it is there's only a y, correct? Is there an x that you see up there? So if it's only a y, are they horizontal or vertical lines? Horizontal. There's y-intercepts. This is how you get parallel lines real easy that are either horizontal or vertical. You see how the y is greater than 3 or less than 6? You see these two vertical lines, horizontal lines right here? It's y equals 6 and y equals 3. So when you see this represents two horizontal lines in this case. If it was an x, it would represent two vertical lines. Okay. We'll do 1A. We'll take some notes as we write these down a little bit. Where'd my pen go? This is on page 155. Sorry. There we go. So this first one, you see how there's just an x? So is this going to be horizontal or vertical lines? Vertical. So how you graph this one is you have two vertical lines, and they're going to be at x equals -2 and x equals 6. So I'm just taking the two numbers, there we go. The two numbers that make on up either end. It's an x, so it's going to be vertical lines at x equals -2 and x equals 6. We have quite a few of these lines on here. Sometimes it helps to label them so you know which ones you've done. The second one is just a Y, so those are going to be your horizontal lines. So this one is going to be two horizontal lines, be Y equals 1 and Y equals 5. We have a rectangle. And the third line here would be a Y and an X, so that has to be slope-intercept form. It makes it more entertaining. Get lots of different colors on there if you use different colors. Not a requirement. No slitting of wrist, please. So which triangle do we use? None of them. We have to be between the horizontal, between the vertical, so it has to be in this rectangle. Look at this one right here, and you see how it's less than? So less than would put it right here.
Wait, no. Negative. Isn't it supposed to be +3?
This +3, right? 1, 2, 3.
Oh my gosh, I'm looking at the wrong one. I know, you were looking at that line.
Yeah.
This is why I should use that.
Yeah, that's fine. You can use okay. It's not a triangle, so we're not necessarily always going to have triangles now. Okay, but this is a bounded region. Okay, this is our bounded region, and we have to list the vertices next. So we're going to make a table here. I'm going to list the vertices vertically here. So I'm just going to go through. Does not matter the order. 2, 5. 6, 5. One, 2, 3, 4. Next one, 4 of them. Two, 4. 1, 2, 1, 2, 3, 4, 5. Start from the origin. Don't start from the red line, or don't start from your graphed lines. Always start from the origin, which would be right there. So we're starting from.
Yeah, that's what confused me.
1, 2, 1, 2, 3, 4, 5. Also, you know that top red line is y equals 5. So if it's on the top red line, my top red line, it has to be 5. If it's on the bottom red line, it has to be 1. Okay, so this is, up to this point, this is stuff that we've done before. Hopefully this is getting a little bit more comfortable with us. Graphing's getting a little bit easier. Okay, that's the hope through all this. Okay, so I have the vertices. Next, I'm going to do the function. So I'm going to take negative 5 times x plus 2 times y, and I'm going to get a value for that. So the function goes right next there. This is what I have to calculate. And I want to find out what these equal. And I'm looking for the minimum and the maximum. So for me, I would take negative 5 times negative 2 plus 2 times 1. And I get 12 there. So this function could represent how much money they make on certain products at this rate. So you kind of go through, you're going to plug each one of them in. This would equal 0. $20. Put them in order. So what's the highest value that I have? So that's going to be our maximum. Lowest is 28. So our final statement, our answer statement, we would say a maximum of 12 at negative 2, 1. Minimum of negative 28 at 6, 1. So all that lovely work to figure that out right there.